My research all focuses in the musculoskeletal area. My fundamental training is in biomechanics, so I came with a mechanical engineering PhD, but I came out of a clinical department, so I was trained in surgery and in preclinical models. I did a postdoc in molecular biology and then developed my research program, which really is focused on biomechanics and regenerative medicine as applied to the musculoskeletal system. So we work on a number of technologies that are really designed to either deliver stem cells, for example, that would regenerate musculoskeletal tissues, muscle, bone, cartilage, or we design technologies that create a regenerative niche that induce the host cells to regenerate those tissues as well. And then we have a side of the lab where we're interested in more fundamental issues like how does the in vivo mechanical environment influence the regenerative process or degenerative conditions like osteoporosis and osteoarthritis. For example, using biomaterials or extracellular matrix technologies to inject into an arthritic joint. If you can regenerate the surface of that joint or perhaps slow down the degeneration, perhaps individuals wouldn't need to have total joint replacement surgeries. And then, if we look further on in terms of a grand challenge, this new project we have for victims of landmines, you would make a huge difference in a child's life if you could turn just an above-knee amputee into a below-knee amputee by regenerating just a portion of those tissues and perhaps getting some joint function to make it into a below-knee amputee. That would make a huge difference. I've always been interested in trauma and in degenerative conditions, and I think it was really as an engineer looking at what are the tools and technologies that we're developing, how can they most benefit patient care. I have some personal experience in this. My daughter had a condition in the spine where she had one vertebra that was actually slipped 80% off another vertebra. It's a condition called spondylolisthesis, which is similar to scoliosis. And they had to realign her spine and fuse it into place, and that didn't work the first time. And she had to go through a long rehabilitation and come back and do the surgery again. And the second time they used a biomaterial to deliver a very potent osteogenic factor that helped to fuse her spine in place. And she's now doing very well. She's back playing competitive tennis and doing great. So that's just one example of where regenerative technologies and having biomaterials that can deliver these really potent biological factors can make a huge difference in a patient's life.